On today's episode, we're going to take a look at this, the Voxelab Aquila S2. It's an Ender 3 V2 clone at the same price, $279, but it has a PEI Metal Flex plate for a bed. It has a direct drive extruder and an all-metal hot end, which will take it up to 300 degrees, so you can print high-temperature plastics. So let's check it out on today's Filament Friday. This episode is brought to you by these Patreon supporters. I received this from Voxelab to do a review, and I'm not really going to do a full review, but I want to give you my first impressions. It comes as a kit. I mean, you got to put everything together just like an Ender 3. So I did that. I put it together. It took me about 45 minutes to put this together. It's very similar to every other Ender 3, so it wasn't tough. And the wiring is actually a little bit easier because some things were already connected. But I did run into one issue, and that is with their mount for the spool holder. The screws are a little bit too long, so they bottom out inside the rail, so this was loose. So I ended up just using a bracket from an Ender 3 that I had removed and replaced, and that fit just fine. They do include a printed manual, which is actually pretty nice, and they also include 4 different filament samples. Now 3 of these are high temperature. In fact, one of them is a filament I've never even heard of. It's a PAHT, and it prints at 260 to 280 degrees. That's pretty hot. Now, I did look it up, and it's a very strong filament, and I was able to print a CHEP cube with it. Now, I did set the bed at 100 degrees C, so the bottom of it got too high. It did reach 100 degrees, but it did take a while. But this printed actually decent at 280 degrees. So the hot end gets up to 280, no problems. I had no errors, no failures. It's a little bit rough, but I would expect that from a higher temperature filament. And I haven't tuned my profiles for this, but it did print this quite well. They also included some PETG or PETG carbon fiber filament. And this stuff is a little bit rough, but I ran it at the max 240 degrees C at the 80 degree bed, and this thing liked it. It actually printed this CHEP cube very smooth. It's a nice looking CHEP cube, especially with carbon fiber. Now, I also noticed they included a test print in the box. This looks like it's the same carbon fiber filament. It's a benchy, but not quite the same benchy as Daniel Norrie, so it looks like they modified or made their own, but it looks like the same material, and it's a good print. But I really like the way my CHEP cube turned out. It's quite smooth, so this machine really likes this carbon fiber filament. They also included some standard PETG and some PLA, but actually PLA carbon fiber. But their temperature was like 210 to 230, so I'm like, well, that's not high temp. So it wasn't a big deal. So now I was more curious how it would handle just standard PLA. How good is this hot end with a low temperature PLA? Which my Filament Friday filament that I used to sell, don't sell it anymore. It's a low temperature PLA, about 195 to 200 degrees C. So I ran that through this, and I got a really nice CHEP cube here at 0.2 layer height. So even though it's a high temperature hot end, it does a good job just with standard PLA. Now, most Ender 3s are Bowden style, so they have an extruder, PTFE tube going in, and then that PTFE tube goes all the way to the nozzle. So you get above 235 degrees, you're starting to break down your PTFE tubing. Plus, printing flexible, it wants to escape the extruder, and it's a little more difficult to do on a Bowden setup, going through that tube. It's possible. I have a profile for that. So I use that same profile on this, but this is a higher temp TPU. It's 220 to 260. It's not the super flexible stuff, but it's a higher temp. So I ran it at 250 on this guy with my profile, which is slower, 20 millimeters per second. So I didn't push it on speed. But I printed this right here. It's a flexible Octopus, pretty common print for flexibles, and it did a great job. There's really no gaps. I printed at a 10% infill. I can squeeze the head, and it doesn't escape, create holes. It did a very good job printing it first try. So my first impression of the quality of the prints, it's pretty good. And this high temperature direct drive extruder is working really well with a lot of different materials, even though I haven't tuned them all to the proper Cura setting. So it's working really well. And I do like this PEI bed. I'm not a big fan of PEI beds, but this one seems to work really well. It's rough on one side, smooth on the other. It's got a strong magnet to hold this in place, so I don't think you gotta worry about it overheating. And like I said, I did bring this up to 100 degrees C at one point. The bed was fine. But the one area I hope they improve is the firmware. The firmware worked well enough. Obviously, I was able to print things, no problem. But little things, like when I tried to use the load and unload filament, first of all, it gives you a picture of a Bowtube setup, so it doesn't even match the printer. And second, when you do that, Marlin that's properly set up will ask you what temperature filament or what filament you want to use so it can adjust the temperature accordingly. This only offers PLA and ABS, so when I tried that PAHT, I had to manually adjust the temperature up to load that stuff. So that's an area they can improve, especially if they're going to do a high temp hot end. Another thing, I was able to level the bed with my electronic leveler, but it didn't have the items on the menu to move to each corner. So I had to run the code that I have for this, the G code that I offer for this, and then it was able to move, but it would run the M0 pause, but not the M25. The M25 just wouldn't stop to go to each corner, just keep going. But the M0 did work, and I was able to get a really nice level on this bed. I did talk to Voxelab about the firmware, and they said they are working with an open source third party, and I think I know who it is. Same one that I've recommended that you update your Voxelab printers to in previous videos. So if we get that, we'll probably also get firmware for auto level sensor. So $279 plus the price of an auto level sensor and that new firmware, you probably can build a heck of a machine. Now I've got an Ender 3v2 that I've showed on the channel. I installed auto level. I installed the Slice Engineering heat break for higher temperature to get rid of that PTFE issue. It's still Bowden, but I really like the way that thing prints. But this may be even better because of the direct drive. I don't know. But it's definitely an option worth considering if you're thinking about getting an upgraded printer. But wait for that firmware before you really jump in with both feet. I did take the bottom of it apart and looked at the board. It's a pretty standard board. There's no ferrules on the wires. It's just soldered wires. And I did verify that I have an N32 micro. This is something you want to make sure you get the right one. They offer an N32 and an H32. N32 is supported by the third-party open source firmware community. The H32 is not right now because of some driver issues, so you have to go through Voxelab. So I recommend you get the N32 micro version of this machine. If you like what I'm doing here, maybe check out some of the other videos that are popping up. And if nothing else, click on that CHEP logo and subscribe. I'll see you next time right here at Filament Friday.